Well, good morning, everybody. It's Jeremiah, and we have a staple in the series of Land Effects webinars today, our hardware recommendations. And yeah, due to certain scheduling reasons and all sorts of reasons, we weren't able to do this last year. And we definitely heard about that. People were used to it. So we are definitely back. We promise we'll do this every year, right in time for you to fill out your Christmas list. Dear Santa, I want a new computer, right? Hey, before we get going, I just have a quick housekeeping item. We are, of course, recording this, so you'll be able to send it to Santa. And also at the bottom of your screen is a Q&A button, questions and answers. I'm sure there's going to be some. It's fine if they're super technical or if we're being too technical, ask in there. But if you click that now, you'll get the little Q&A box, and you're going to be able to see the answers that we type to other people's questions. Might have been something you were just about thinking of asking. So it makes a great companion while you're watching this webinar live with us. So do feel free to chime in with questions. We like to know that you are actively watching and paying attention and have thoughts in your head, and the Q&A is kind of our only way to know that. So please feel free. That being said, hey, I'm going to hand this over to Mike Bennett, and he's going to take it away.
All right, thank you, Jer. Welcome everybody to our hardware recommendations for 2023. As Jer said, I'm Mike. I am currently the cloud infrastructure admin here at LandFX. Something I've worn several hats here with the LandFX team, so I consider myself a jack of all trades, master of none, as I kind of bounce around and do what's needed. So let's take a look at what we're going to be reviewing in today's webinar. First of all, we're going to take a look at understanding your needs. That, anytime you're looking to replace equipment or upgrade something, you got to know where you're starting from, what you need it to fit. So we're going to start there. Then we'll dive into the anatomy of a computer. I know that's a weird thing to say. It's because it's an inanimate object, but we'll kind of do a little. We're not going to get too intricate, but take a look at the components that make up your computer and why you have to upgrade it when you do. Cloud computing is next up. That is something that's come up not a few more times, more and more frequently now. It's more going to be used in the enterprise space, or if you have an IT team, it's better for environmental control, things like that. But it also enables you to kind of work in a hybrid environment. So we'll take a look at that as well. Tablets. These pop up every so frequently. We get people reaching out asking, are we compatible with tablets, this and that. So we'll touch on that. And then we're going to take a look at some tips on actually choosing a computer. Things to look for, shopping tips, what components to be actively pursuing, that sort of thing. And then we'll get to our top picks. Now, this is really the what I feel like a lot of you are here for, is to see what systems we actually recommend. Now, we're not going to be diving into like exactly this particular model or that particular model. I have a few examples like that because we really have to, but with the way that technology changes and the markets develop, there's a good chance that 6 months after this webinar is out there, one of the very specific models we have will either no longer be available or the price will be drastically different. So just a reminder that this is kind of like a guidebook, like it's a framework for you to be able to go out and have the tools you need to be able to make the educated decisions. It's not like a 1, 2, 3, do this, do that, and you're going to end up where you want to be. So just bear that in mind. Then we'll touch base on Apple. What's the status with them since they switched to their M series chips, how that affects AutoCAD users, and your everyday workflow. We'll touch briefly on some accessories and add-ons that you can really use to pad out your workspace. Things that'll help you with your professional working environment if you are mobile. And then we'll wrap up with some maintenance tips. So let's go ahead and dive on in and start with understanding your needs. Ah. So with our recommended specifications, these are passed down from Autodesk. So since LandFX is an AutoCAD plugin, We need to have the same recommended and minimum specifications that Autodesk has, because in order to use our software, you have to use a CAD engine. For 2024, Autodesk did what appears to be a mid-session refresh. You're still looking at 64-bit Windows 10 or 11 for both recommended and minimum specifications. So, if you're on anything older than Windows 10, you're way past end of life at this point. So your system is a security vulnerability, and that can spread to anything on your network. So make sure you're running at least Windows 10, or preferably Windows 11 is the current gen. If you upgrade to Windows 10 at this point, you're just going to be doing it again, in a year, and nobody wants to go down that rabbit hole multiple times. Once we get to RAM or memory, Autodesk is now recommending 32 gigs. In my personal opinion, that's overkill for a CAD workstation. I mean, if you are working on some massive civil files, maybe, but I don't write the CAD engine, so they say it's 32 gigs, so we say it's 32 gigs. Minimum spec is 8 gigs. If you're buying a modern computer and you're specing it with less than 8 gigs of RAM, you're just setting yourself up for a world of hurt down the line. So consider 16 gigs to 32 gigs, good starting point. Solid state drive, that's a non-starter. Like we're in 2023, about to enter 2024. I can't believe this year is gone already. So solid state drive, minimum. They're standard on most computers. If you're considering a computer and it tells you it's got a hard drive instead of a solid state, you might want to consider a different model, because that's going to be a very budget oriented computer. Once we get to your processor or your CPU, your central processing unit, that's what handles all of the heavy lifting for your computer. Autodesk wants a 4+ gigahertz turbo speed on the processor. We'll touch on that next. For your graphics card, your video card, your GPU, what's the word? Acronyms for days. For your graphics card, they recommend 4 gigs of onboard memory minimum, and DX12 compliant for recommended spec, DX11 compliant for minimum spec. We'll touch on that as well. So all your modern processors have a minimum and a max speed. Your base clock, or your minimum speed, is where the processor sits when it's not in use. When you're sitting at your desktop or you're checking your email or something like that. It's low power consumption, lower heat output. It's where you want to be 90% of the time when you're just, trolling around on your computer. Once you're actually trying to do things, your turbo clock is the limit the processor will boost to under a load. So you're going to have much higher power consumption, much higher heat output. And especially when you're working with laptops, these turbo clocks are going to be burstable loads for the most part. They have a relatively small footprint, high thermal capacity or low thermal capacity, small footprint, small thermal space. So when they turbo boost, they're usually not going to be able to maintain those max clocks for very long. So when Autodesk recommends a 4+ gigahertz turbo clock, that's the max speed of the processor. And current generations of chips I don't think the last 2 generations of chips have been below a 5 gigahertz boost clock. So if you're looking at modern spec, that's going to be 13th gen Intel, 14th gen now. You really won't have to worry about that at all. So graphics cards and DirectX. DirectX is an API, something that you will never use. It's for Autodesk for their CAD engine, but it allows their software to interact directly with your graphics card. And all of this is for efficiency gains, lower power consumption, lower CPU overhead, more efficient operation. An API is a translation layer for one software or application to talk to another. In this case, it's AutoCAD to talk to your graphics card. Your benefits of DirectX 12 are CPU multi-core support. So modern CPUs have anywhere from 6 to 20 cores now. DirectX 11 is single-threaded, so it can only use one of your CPU cores. Along with that, DirectX 12 brings lower CPU overhead because it can now leverage multiple cores and it's more efficient. It reduces the strain on the CPU, which reduces your overall system load for some operations. Flip side of that, well, not flip side, but in addition to that, DirectX 12 launched in 2015. So realistically, if you're specing a modern system, it's going to be DirectX 12 compliant. In that sense, I mean, maybe they have it on there in case people are trying to recycle 10-year-old systems, but for the most part, if you're buying a new computer, you're going to be DX12 compliant. The anatomy of a computer. Again, odd analogy, but I felt like it worked for this one because we are taking a look at what makes up a computer. If I can find, there it is. So you've got your computer itself, your computer monitor, and your accessories, keyboard and mouse, docking station, whatever else you might have. This really comes back to when I used to work in a computer repair shop. We'd have people, call in and say, we've got this going on with our computer. We'd tell them, all right, bring it on down. We'll take a look at it. And people would show up and they would have multiple crates of stuff and they'd bring us the tower and the monitor and their printer. And so before you really dive into figuring out before you go shopping for upgrades for your computer, it's best to understand what it is you need to upgrade. Inside of your tower itself, you've got all the individual components of your computer. Primary ones are listed here. We have, first up, your processor or your CPU that handles all the heavy lifting. That's what does all of the calculations. Anything you do on your computer goes through the processor. Your RAM and your memory, that's random access memory. And that's where content is actually worked on. So anytime you load a file or you load an application or you boot your computer, your content is pulled off of the SSD into RAM because RAM is exponentially faster than your data access off of the solid state drive, even though solid state drives are exponentially faster than old hard drives. They still don't approach what RAM can do. For everything that you see on your screen, some calculations in CAD, gaming, things like that, that all goes through your graphics processing unit, your GPU, your video card, what have you. As far as the lifespan of these components, your processor, your CPU, for the most part, you can expect 3 to 5 years. Now, realistically, CPUs, processors, they will go for decades. They're not a wear item. Without external influences coming in, power outages, brownouts, power surges, liquid spills, short circuits, things like that. Without external influence, processors will run for decades. The reason they're on a 3 to 5 year upgrade cycle or replacement cycle is simply because technology advances that fast. By the time your processor hits the market, so if you were to go out and shop right now, if you were to go out and buy a new computer right now, the processor that is in it, even if it just hit the market 2 months ago, the manufacturer is already 6 months into producing the replacement, 6 months to a year. So technology advances so fast, your peripherals or your accessories may have to leverage new technologies and processors. So that's why they're on a 3 to 5 year replacement cycle. RAM, again, that's a decade long item. In all of my years working with computers, the only times I ever see failing RAM is usually because of user error, either poor installs, electrostatic, things like that, power surges. So we're back to the external influences. Solid state drives. You can expect 3 to 5 years on average out of a solid state drive. Now, that is a very rough estimate because they are wear items. Solid state drives have a limited number of read and write cycles. So depending on how much data you read and write on a daily basis, that's going to dictate how long your drive is going to last, as well as how large your solid state drive is and how much data you end up throwing on it. Because I mean, if you spec your system out with a 256 gig solid state drive, sorry to say, but you're going to run out of space probably within 6 months. So lots of variables to that. Your graphics card or your GPU, those will easily run for 5 to 10 years as far as just operational standpoint goes. Now they will be outclassed a lot faster than that, but for CAD use, as long as drivers are still available and it still meets the memory requirements, graphics cards can honestly be pushed for quite some time. So why the 3-year replacement cycle? Well, inside of your computer, inside of every computer, you also have a motherboard or a logic board. All of your components in your computer connect using it. You can consider it the backbone or the nervous system, I guess. Your CPU, your RAM, your solid state, and your graphics card all connect to each other through the motherboard. Store-bought systems, Dell, Lenovo, HP, almost all of these big name brands are going to be using proprietary motherboards. And that means that they have motherboards that are designed specifically for them, for their exact use case, generally to provide optimum port layout, to remove non-necessary features, to save on costs, things like that. Makes a lot of sense from a manufacturing standpoint. But from a user standpoint, it does affect your repairability and your longevity of your components or of your machine. The problem with proprietary motherboards is that you are reliant on parts availability from the manufacturer. Boards tend to age out of rotation quickly, and they tend to have a unique design per case. What this means is, again, we're circling back to that once your product launches, your manufacturer is already several months into producing its replacement. So if the manufacturer produces a new model of that computer every year, they're not going to continue stocking parts for the old model for more than 4 to 5 years. So if you try to keep your computer for 6, 7 years and your motherboard goes out, well, at that point you are completely stuck either trying to find parts on the used market, which when you're talking about motherboards, generally not a good idea because who knows how much life that has left in it. So these are all considerations that are taken into effect when you're talking about the 3-year replacement cycle. It's primarily parts availability, ease of repair, and how long you would be down for if something went down. Because when you're relying on something for your everyday business use, you need it to work. Now, if you have a laptop, unfortunately, this takes it in an entirely different turn. Generally, they're not upgradable or serviceable for the most part. Proprietary motherboards are almost a guarantee. I have yet to find a laptop that did not have a proprietary motherboard. Most modern systems have direct soldered components. What that means is your CPU, your RAM, your GPU, they're all soldered directly onto the motherboard during the manufacturing process, which means they're not user upgradable, they're not user replaceable. If you end up needing a repair on a system like that, I've had several MacBooks over the years repaired for various issues. Generally, it involves a replacement of the entire logic board. When the components are direct soldered, they're generally called a logic board. So in a laptop, your lifespans tend to be lower, again, because we're talking about a small enclosure, high heat density. So that affects component lifespan. Also, it's a laptop, so you're moving it around, you're jostling it, and you tend to take it with you, work on it while you're doing things. So liquid spills and hazards like that are more commonplace. And most repairs for laptops have to go through the manufacturer. Generally, again, because it's a proprietary system, direct soldered components, they have access to the parts on hand to just be able to swap in a new one off the shelf. So why do you upgrade your computer every 3 to 5 years? Simply convenience. If it boils down to it, at 3 to 5 years in a product's life cycle, your motherboard is likely discontinued, your solid state drive is likely nearing end of life, and your CPU is likely outpaced, and your GPU is likely outpaced. Now, notice how we say likely. There's no way for us to say that for sure these are going to be factors that come into play. It's a convenience thing. At 3 to 5 years after you bought your computer, half of the components in it are going to be out of date. The other half are going to be discontinued. So when components start to fail, how much time do you want to spend trying to track down parts and fix it? How long can you afford to be without this computer while you're trying to track down parts and fix it? If your motherboard goes out, generally you're going to be looking at a week minimum to get that replaced because you've got shipping time, and honestly, the repair time for something like that is the actual process of swapping it is relatively quick. You can, depending on the system, you can do that within a couple of hours. Solid state drive, that's easy. couple of days tops. Those are such commonplace now. You can pretty much go into any box store, Best Buy, Circuit City. Nah, I don't even think Circuit City exists anymore. Best Buy, Fry's, are they still around? I don't know. I live in the middle of nowhere. I have a Best Buy. But you can pretty much go into a box store and buy a solid state drive off the shelf. So that's a couple of days tops. Processor, that's limited by your motherboard. Every processor has a specific socket that it goes in. So your motherboard has to be compatible with the one that you intend to replace it with. Chances are, if your computer's 3 to 5 years old, you're either going to have to buy a old generation processor to pop back in there. So now you're spending money to put the same equipment back in, or you have to upgrade the computer. Graphics card, that might be limited by the motherboard. That's going to be a lot rarer because they are backwards compatible. They will downclock. So if your motherboard runs an older version of the PCIe spec, it'll still work. But it may also be limited by your power supply. Something has to take that 120 volts out of your wall, or 240, depending on where you are, and convert it down to 12, 5, and 3 volts. And as we saw with the NVIDIA 40 series launch, they introduced an entirely new plug, which was not good, by the way. That was a garbage plug that has had its own fair share of problems, but that component by itself rendered older power supplies kind of obsolete for the new gen. There were adapters that made it work, but not properly. And driver availability. Once you've got a motherboard that's 3 to 5 years old, if a new operating system comes out, like Windows 11, for instance, your computer manufacturer may not release updated drivers for Windows 11. That being said, Windows 10, Windows 11, they're close enough that generally Windows 10 drivers work totally fine. So for this generation, not a huge deal. Going from XP to Vista, though, as an example, I know it's going way back and dating myself. That was a bigger jump, and there were a lot of issues with drivers making that transition. So that's something to keep in mind as well. Yes, you can totally keep your machine running for more than 3 years, but once you start crossing these, words in my brain today, not landmarks. Once you start crossing these milestones, things become a bit more time consuming to keep working correctly. And don't forget your time spent sourcing parts. If you're doing any of this yourself, it may take you a little while to make sure these parts are compatible. Your processor, your GPU, your solid state drive, motherboard, all of this has to be taken into consideration because all these parts have to work together. Okay, cloud computing. Like I said, this has come up more and more in frequent years, especially after COVID and the work from home situation. Mostly it's with IT teams, corporate teams, when they need to control environments and what's on computers, things like that. Cloud computing is a viable option for these workflows. Now, what is cloud computing? Well, you pretty much take a computer and you shove it up into the cloud. That is what it is. With cloud computing, you're not doing anything new. You are working on a computer that's in a data center that's connected to the internet. So instead of everything happening on your local machine, it's just happening somewhere else, and you have a viewing window into that. There's already several providers in this space. Primarily, we have AWS and Microsoft. We've got several offerings from both, and they both have their pros and their cons. So with cloud computing, a couple of pros, you've got low to zero maintenance. Again, you're just looking at a computer that's in another location. So you don't have to maintain it. You don't have to keep up with any of these hardware changes and trends and things like that. It's available anywhere you have internet access. Now, that's also a con. You need internet access. Cloud computing is that is not something that will work offline, plain and simple. You're able to work from almost any device. If you really wanted to, you could connect to your cloud computing device from your cell phone. You could start a remote session from your phone and work on that, little 6-inch screen if you have magnifying glasses for eyeballs. I don't. You also have minimal recovery time in the event of local hardware issues. So if you were running a 5-year-old computer and your motherboard went out, for instance, or your power supply went out, what have you, as long as you have a spare machine, a tablet, something else, borrow a computer from a friend, you can reconnect your cloud workspace and all of your software, your settings, your files, everything is still there. So your downtime is only as long as it takes you to get a computer to reconnect to your cloud instance. Now, some cons, and these are big ones. Complicated configuration. That's not to be taken lightly. Some of these options or setups can be quite involved to set up. Your cost will tend to vary month to month. Most of these services are billed by the hour that your equipment is turned on. So if you're working 8-hour days, 5 days a week, for 4 weeks a month, you're talking 160 hours a month. So that's something to keep in mind. It still requires you to have some sort of computer on your end. You know, it's not a completely cloud-based system where we haven't reached the point where you can just take a screen and connect it to it, although some smart TVs might be nearing that. So who knows? And pro or con could be that there's multiple platforms available, and that provides a lot of options. Unfortunately, those options can be quite overwhelming. And so let's take a look at what I mean here. To start with, AWS EC2 and Microsoft Azure Compute. These are the two very manual setups. And this is a lot of technical jargon, I know. But trust me, this is quite dumbed down compared to when you're actually trying to spec these things out. And these are just examples of a couple comparable systems as far as cost goes. On the EC2 side, all of these systems have 4 vCPUs. What that means is they're basically given a quad core. Realistically, for desktop use, I wouldn't even bother specing anything less than that. For some reason, with cloud computing, well, it's not for some reason, it's because you're on a shared instance. Other people are using part of the hardware at the same time you are. So a quad core is really as small as you want to go. 16 gigs of RAM. You can see the Azure Compute on the top right has 28 gigs. I'm not really sure where Microsoft ends up pulling their values from. Usually, you know, industry standard is 4, 8, 16, 32. Microsoft kind of changes that a little bit. All of these have a GPU that meets the recommended specifications, with the exception of the bottom right offering from Azure. You'll note that that has 1/8 of an MI25 GPU. That circles back to the shared hardware instance. When you're working with cloud computing, you are generally renting a section of a system. And when it comes to that one, you are renting a section of that graphics card with a dedicated 2 gigabytes of memory. Now, all of these options are sitting close to 180 a month, with the exception of the bottom left from EC2. You're looking about 90 a month. That's an hourly bill. Something to bear in mind with these are none of these include the cost of your storage, the cost of your networking setup, your firewall, your routing. Again, this is all a very manual setup. It can be very complicated to set up. So this is generally something you're only going to be looking at if you have a dedicated IT team or you hire a contractor to set it up for you. Once it is set, if you go the contractor route, bear in mind, you will need to have somebody on staff who can administer these platforms, because when things go wrong, it's not something you're just going to turn it off and on again and hope that it works. Generally, when things go wrong, it's because something needs to be tweaked or changed. Now, they also offer more user-friendly options. Amazon AWS has workspaces and Microsoft has virtual desktops. They're comparable spec, but you might notice the cost has gone up exponentially. Generally, that's because they're taking over setting up and configuring everything for you. Once you have the instance set up or you choose your size, you basically just launch an app on your desktop, and once you log in, it starts your remote machine and connects you to it, and away you go. So it's much simpler from a user standpoint, but you pay for that. And another thing to bear in mind here is all of these are using a 256 gigabyte SSD with moderate speeds. Any changes to your storage type, you have choices between hard drive. Do not use a hard drive with cloud computing. You will be in for a world of hurt and you will hate your working day. Trust me, bad idea. So you got a choice between hard drive, solid state drive, premium solid state. They got to throw premium on it. It's like supersize me. Your speed and your size affect all those prices. And that's something, if you want to pursue that route, you'll really want to poke around with on their platforms because those prices change frequently. Before we dive into tablets, did we have any questions we need to touch base on?
I think we're good. We did have a great question on just how is cloud computing security handled.
Mhm.
And I think that's a pretty good point. But I believe it's just username and password, but the cloud providers are gonna be sure that no one's attempting to just brute force guess usernames and passwords. So yeah, I think you're safe from that, but you would want to be sure you're using a good password and change it occasionally, right?
Yeah, so that also will touch base on the differences between when you're looking at AWS's EC2 and Azure's computes, as opposed to their virtual desktop platforms. If you're doing EC2 and compute, you are in total control of all of that. So you have to set up your password rotations or your security key rotations, things like that, to make sure that you stay secure. And you also have to lock down your networks to, you can either restrict access to your machines to your specific IP address, preferable, but manual configuration, your ISP has to provide you a static IP, or you have to go in and change that every time it changes. Um, Now, when you're working with the virtual desktop options, those are going to be more automatic, and those are all connected via username and password. You don't have access to go in and say, um, lock. Actually, you might still have the ability to lock it down to your IP only, but for the most part, the security aspects are managed by the platform.
Gotcha. Okay, cool.
All right. So for tablets, how's their overall compatibility? Realistically, not much. Um, they pretty much have native drawing viewing only using Autodesk's AutoCAD Web. It's $100 a year, so you know it's not substantial. But it has no editing capabilities. You have very limited markup features, and you're usually on a very small display. The pros for tablets are that they are compact, lightweight, and they're low power devices. Unfortunately, the cons are also that they're compact and they're low power, and most are mobile operating systems, which means you are locked into a specific ecosystem as far as app availability and what you're able to do with them. Now, can you do CAD on a tablet? Yeah. If you combine cloud computing with most tablets, you can totally run AutoCAD on a tablet. Air quotes around run. This is an example workspace you would see on a tablet. Not that bad when you're looking at the CAD window on the left. Now, that same CAD window in actual space is on a 9.5-inch display. So you are going to be sitting so close to this thing. Uh, uh, I don't know about, I like my back a little bit more than that. I don't want to be sitting that close to my screen. um, if you were going to be using a tablet out in the field for just looking at a drawing, sure, totally viable. I would not be considering a tablet to replace your daily driver for a computer right now. The Microsoft Surface lineup, because that's generally what people bring to the table when they're asking us about tablets. The Surface tablet does not have a discrete GPU, so it does not meet minimum specifications. Can it work? Yes. Is it recommended? No. All right. So choosing a computer, a couple of things to look out for. Uh, Primary considerations when you are in the market: budget. Be realistic. You are buying a workstation. This is for your business. We're not going to Walmart and buying a $300 bargain bin computer. You want to start with the system requirements. That is your framework for what you need to be shopping for. And you want to work down your product lines. When you start looking for a computer, it is going to be overwhelming. You're going to see hundreds of options. Even if you go to a specific manufacturer and you go look at and you go hit their workstations tier. I ran into the same issue when I was looking for machines for this webinar. You hit workstations and you just get inundated because instead of giving you one model, and then letting you pick that. And then it goes in, and then they go into, well, this model has all of these options. They just throw everything on the page and you are left to your own devices. Post-sale support, that's important. It's a computer. Things are going to go wrong. It's electronics. It's 2023. Viruses, you know, we all click on stupid things in emails sometimes. That happens. And it's also electronics. Manufacturers are making thousands of these things every day. So bad eggs slip through the cracks. Will you have local repair options? And are you prepared to mail in your PC? Both of those are going to kind of determine what brand availability you have, because if you have to have a local option, you're going to have to buy what your local providers will sell you. Flip side of that, if you want to go with a Dell, but you don't have anybody local who sells Dells, you're going to have to either be prepared to have them send their in-home technicians if they offer them in your area, or you'll have to be prepared to mail it in, which means you'll be without a computer for a couple of days. And product lifecycle, how well does your brand hold up? If you're planning on keeping your computer for 3 to 5 years, are you buying a brand that holds up for 3 to 5 years, or are you buying a brand that you may end up repairing one or multiple times before you hit that point where you're ready to just replace it? And lastly, is it serviceable? The serviceable component mostly goes out the window when you're looking at laptops, again, because everything's gone to such low profile. Most components are direct soldered. There are other benefits to that, but for the most part, serviceability is going to be a factor if you're looking at desktops. Now, a very good rule anytime you're shopping for anything, it's the KISS rule. Keep it simple, stupid. If you are preparing your workspace and you are potentially going to be working in the field, or you're going to be moving around at all, you're going to need a mobile setup. Go with a single powerful laptop, no eGPUs. Same thing. If you prefer a desktop setup, go with a single powerful tower, no eGPUs. Simplicity is king. The less components you have in your day-to-day working life, as far as your computer goes, the happier you're going to be. Because when you have a desktop and a laptop and you try to use an eGPU either with one of them or both of them, not only do you now have 2 computers you have to maintain, now you have 2 computers that have different software packages on them, different settings, different files. So every time you move between them, oh, well, that's right, I installed this over here. Now I have to install that over there. Simplicity is king. So things to avoid: multi-system deployments, tablet, laptop, plus a desktop. It's a headache and a nightmare. Cloud computing without IT, again, it's a very manual thing. It's very involved to get it going, and it does require a little bit of maintenance here and there. When they do upgrade components, sometimes you have to go in and change settings. And if you're not comfortable doing that, you need IT. So you don't want to rely on cloud computing if either you're unable to administer that or you don't have somebody who can. And water cooling, I threw this on here because it is becoming more prevalent in some brands of computers. Water cooling is cool. It, no pun intended. It does work, but you've now introduced multiple points of failure just for a cooling component when you already have the points of failure of the computer. So simplicity is king. Avoid water cooling. All right, so some of our top picks as far as computers to consider. The Dell XPS lineup. These make it almost every year, I think these have been in here. And it's because they are highly rated workstation machines. They're thin, they're lightweight, they're portable, the build quality's up there. Now, in their current generations, they're available in a 15 and a 17 inch. They have a lot of different configuration options available. They have OLED display, so they have a very good display. They're available with the 40 series graphics cards, so current generation, that's what you want. And they have Thunderbolt 4, so they have fantastic expandability. With Thunderbolt 4, you can use Thunderbolt docking stations, so you can use a single connection to go from your computer to your monitors, your keyboard, your mice, your Ethernet, your power delivery. So if you go from home to the office or out into the field, you can use a single connection. You plug one cable into your computer, and now it's charging, and you've got everything on your desk. So Thunderbolt in that regard is very useful. And these guys start as low as $1849 in a spec that meets the recommended specifications. Touching on the system specking note, when you are shopping for computers, desktops aren't affected by this quite as much. It's primarily going to be laptops. Avoid max spec CPUs and laptops. So on the left here, you see the 13900H. That is the top of the line CPU for 13th gen. That is a waste of space and money in a laptop. And that is due to thermal throttling. Because they tend to have a small footprint, once that processor ramps up for a workload, you are going to hit your temperature cap really fast. And once that happens, the system starts slowing itself down to maintain temperature. And once that starts taking place, I mean, you may as well have saved the money and gone with the lower end CPU. Gives you a little bit more thermal headroom before you run into throttling. So you might actually be able to run at those turbo clocks for longer before it has to slow itself down. So save yourself some money, and you realistically will end up at relatively the same performance overall. For this year, we're adding HP to the lineup. Their ZBooks have actually been trending really well in the workspace environment or workstation environment. They only offer a 15.6 inch or a 15-inch laptop. They have both AMD and Intel options. In current generations, I think AMD is winning on performance or value. They're also winning on energy efficiency. You have 1080p and 1440 displays. 1080p in a laptop is totally fine, honestly. I mean, for the most part, I only work on my laptop on the laptop screen when I'm moving around or something comes up when over the weekend or something like that. So for a 1080p display for a laptop, it's fine. It's getting a little dated at this point, but it is easier to drive and it's cheaper. You have AMD and NVIDIA GPU options. Just remember, as long as they have 4 gigs of RAM, you're meeting that recommended spec. So you got pick of the field there, and they both have Thunderbolt 4. These guys start around $15.99 for comparable options. So, for a new workstation for a laptop that can theoretically last you 3 to 5 years, $15.99 is not bad. Framework laptop. This is a newcomer to the field, and unfortunately, their 16-inch offering isn't quite fully out yet, but I wanted to mention it because it is a cool newcomer to the field. They've already won several product awards. I believe they were featured in Time magazine as well. But they are highly customizable. They're fully modular, and nearly all components on the computer are user replaceable. So this circles back to that user repairability factor and how long you can make your computer last. Now, these guys are obviously quite a bit more expensive than the other offerings we saw here, but that's due to what you're able to do with them. So all of these components are designed to be replaceable by the end user. All of your ports on the sides of the laptops are in these little modules that will slide out and slide in, and you can replace any of them with any of the options on the left-hand side here. So you can create your own combination of ports to suit your workflow. If you have switched entirely over to USB-C, you can swap most of them over to USB-C. If you need an HDMI or a display port, you can pop that in. You have a 2.5 gig Ethernet option, which is impressive. I'm still seeing most computers coming out these days with gigabit Ethernet, which is pretty surprising. Micro SD cards. If you work with a lot of photography or small form factor systems, things like that, you could use that. And even your graphics card in this is switchable. That's that big expansion bay module on the bottom of that computer rotating through the video there. So Framework's a newcomer to the field. If you're interested in pushing that 3 to 5 year maintenance mark, definitely keep them in mind. You can also buy little cases. So they'll sell the main board or the logic board for the computer separately. So when a new generation comes out, you can actually upgrade your motherboard, your CPU, and everything to the current generation. And they sell little cases so you can take the old one and turn it into a small PC to use for something else. So if you like tinkering with things, that's an option. For desktops, the Dell Precision 3660. predecessor was the 3630, I believe, was rated as the best budget workstation. In this configuration, it's got a 16 core CPU. Way overkill for CAD, but that's what we're looking at now. Most PCs are coming out with 12, 16 cores, so that's awesome. 32 gigs of RAM to meet Autodesk's updated specifications, and a 512 gig SSD. Now that's small, plainly put. 512 is not a lot. I have 4 tears in my computer, and I think I have like 300 gigs free. 512 is not a lot of space. And it's got a 12 gigabyte NVIDIA GPU. Now the A2000 series, that's a workstation series GPU. So it is ISV certified, which means it has drivers that are certified for CAD use, which basically just means Autodesk has gone in and said, yep, these drivers work with CAD. In this configuration, it was $1,859. I know that's not really budget compared to the laptops we were just looking at. If you dropped it down to 16 gigs of RAM, it also drops down the GPU to an 8 gig model, but it drops the price down to, I think, like 14 something. So a lot more budget oriented in that regard. The Lenovo ThinkStation P3, this product line has continually made top lists. Again, same processor as the Dell, 32 gigs. It has a 1 terabyte SSD, so that's a lot better. You'll be able to squeeze that by for quite a bit longer. That has the same 8 gig GPU that the cheaper Dell had, and it's $1,779 as configured. Take all of these prices with a grain of salt because they could change tomorrow. We don't control these things. The ThinkStation P620. This one made top tier, not for budget, obviously. It's got a Threadripper 16 core CPU. Now, before the current generation of 16 core CPUs came out, these Threadrippers were absolute machines. They would decimate any workload you could throw at them. So to get this in a workstation that you're going to use for CAD, is it overkill? Yeah, quite a bit. But it's there if you like that sort of thing. It's got 32 gigs of RAM, 1 terabyte, the same GPU that was in the Dell, but you can see the price difference. It's literally twice as much money for half of the same components. Okay, Apple. Apple, I think, comes up more frequently than, well, it definitely comes up more frequently than tablets or cloud computing, I can tell you that much. LandFX is still an all Mac office. We all use only Apple products. Windows for ARM, however, is still in beta. There's still no official support for ARM from Autodesk or LandFX. We have our own technical staff, and even our team has to start over sometimes. It happens. It's a beta operating system. There is no minimum version of any third-party components like Visual C++ runtimes, .NET, yada, yada, more acronyms that makes CAD work. So what may work fine today, you may find that an update that installed overnight makes CAD crash when you try to insert a callout. Who knows? That's the joys of beta. It's still a viable option, but be prepared for speed bumps. Considerations to keep in mind if you're going with an M series Mac, which is basically any new Mac from Apple. I don't think they have a single Intel Mac in their lineup anymore. You are operating 2 computers. You have your Windows virtual machine and your Mac host machine. Each computer has its own set of maintenance and its own set of problems to watch out for. Each also has its own updates. Not all apps have support for Windows ARM. Shared online folder apps, Dropbox, Google Drive, SugarSync, ShareFile, those type of apps, varying compatibility. I don't think Dropbox has an app for Windows for ARM. I think, off the top of my head. Again, Windows for ARM is still in beta, so no official support from Autodesk. If you go look at their system requirements page, they still under CPU list 64-bit, no ARM. Will it run on an M series Mac running a VM in Parallels? Absolutely. Does it work? Perfectly fine 90% of the time. Absolutely. Is there a chance that something may not work quite like you expect it at some point? Yes. So as long as you bear that in mind, it's you can still totally do it. Just be prepared for things not quite to go the way you expect them to all the time. And be prepared to rebuild your VM. Even internally in our own office, we have had to scrap our VMs and start over from scratch because of an unsolvable issue. It happens. As far as the current litter of Macs, pick your poison. They all have M series chips. They're all relatively comparable as far as CAD use goes. Obviously, the M3s are going to be bigger and faster. Oh my. Um, the one caveat to all of this is I will say the 13-inch M1 would be a very light use CAD machine. Um, Reason for that is they are so low power and so thin that they thermal throttle relatively quickly. So performance in CAD reaches a plateau relatively quickly, and they can only run one external display. So as a primary workstation, the 13-inch Air on the M1 chip is it's a tough one to make work, but it can work. If you were going to be considering any, if you were be, yeah, words are hard. If you were going to be considering an Air today as a new machine, I would start with the M2 series. I believe even the 13-inch supports two external displays. And then for their desktops, their iMac, they only have a 24-inch now. They got rid of the 27. We were actually just talking about that before the webinar started. So if you were to buy the 24-inch iMac and then you wanted a second display from Apple for that, you've got a 24-inch iMac and then a 27-inch display. They don't really match anymore. So bear that in mind. Supposedly they're still really nice though. The Mac Minis, Mac Studios, we run a couple of those ourselves. They're great computers. They're fast. If you don't want the built-in display, go with the Mac Mini or the Mac Studio. The Studio has a little bit more expandability. I think it's got faster Ethernet, but they're comparable as far as your CAD use is going to go. And then for accessories, this is just going to be a short, quick little list. I mean, there are so many mice and keyboard combinations out there. We're just showing you what we use internally. The Logitech MX Master Mouse, this series has been around for ages. I still have one of the original MX Master mice. I think it is the first one. Still works great. I've had it for probably close to 10 years now. So as far as a wireless mouse can go, I don't think you're going to find many that are better than the MX series. They are wireless. You can go either Bluetooth or use their USB receiver. 70-day battery life on a single charge is pretty ridiculous. I mean, when I was using a wireless mouse at my desk, I think I plugged it in once a month, maybe. When I would go home on a Friday, I would plug it in and I never had to worry about it. The 3S has 7 programmable buttons. So if you're a fan of tweaking your settings, or Jer, I believe, likes to put escape on one of the mouse thumb buttons. So kind of assist your workflow in CAD with some of your commands. For this guy, it's got USB-C charging, but a USB-A receiver. So that's something to keep in mind if you have or if you are getting a modern machine that has only USB-C ports. All of Logitech's wireless components still use a USB-A receiver. Not sure why that is. I've been keeping my eyes on that because I'd like to get rid of the USB-A receiver in my mouse when I go wireless. Sticking with the Logitech lineup, and this was a big one for Jer when he was shopping for a replacement keyboard. He wanted something that was wireless but USB-C. And the market for that is actually relatively small, or at least it was at the time. Logitech now offers their mechanical lineup. It's Bluetooth or a USB receiver, which is, again, that USB-A wireless receiver from Logitech, but the keyboard itself uses USB-C. This model, it uses mechanical switches. So if you're a fan of that really clicky tactile feel, if you talk on the phone a lot, I would highly recommend going with the silent switches. But this model has all 3 different types available for your preference. and it has presence and ambient light sensing for the backlighting. So the backlighting will turn off when you're away from the keyboard, and it'll automatically turn on when you approach it or when you put your hands over it, and it adjusts brightness to your ambient light levels. That's kind of a cool feature. And 15-day battery life if you have the backlighting on, 10 months without. I mean, if I went 9 months without plugging in my keyboard, I'd probably forget to plug it in ever. And then I'd turn my computer on one day and spend 20 minutes trying to figure out why my keyboard wasn't working. If you're not a fan of the full 10 key experience, you can go with the Logitech Mechanical Mini. It's basically the same thing, just without the 10 key. So cover that base. Starlink is a perfectly viable option these days if you work on the road or you routinely go out to a cabin to work in the woods for 3 months out of the year. Starlink is a perfectly viable option to get you internet. Myself and Jer both use it as our main ISPs every day. Works great. Since I got mine set up, I mean, it came in, it's in a box. You take it out of the box, you plug it into power, and it does its thing, and away you go. Like you plug in a cable and you're done. It doesn't get much more foolproof than that. They're pay-as-you-go plans, so you don't have to sign a year contract. You have roaming capability. You can strap these things to the top of your roof of your car, drive across the country, and you'll have internet the entire time, as long as you have vision to a satellite. And your plans start as low as 120 a month. Currently. That currently asterisk is important because that tends to fluctuate. But if you work in an environment where you are moving around quite a bit, you may or may not be without internet. LandFX is largely a cloud-based plugin, so Starlink is a viable option if you need to go that route. And now we're coming down to maintenance. For the most part, we're talking about maintenance of your hardware. Maintenance of your software can really devolve. There's so many tools out there now. Primarily, when it comes to your hardware, the best rule of thumb, take regular backups. I'm pretty sure we talk about this in each of these webinars, but backups are super critical. And make sure you test those backups. It doesn't do you a lot of good if you have 6 months worth of backups taking up a terabyte worth of space, but you go to your computer crash and you go to restore them, and it turns out none of the backups actually work. Well, hope you kept good notes about what you had set up on your computer. And remember the 3-2-1 rule. You want 3 copies of your data on 2 types of media, USB drive, cloud storage, that satisfy the 2 types rules, and you want 1 copy offsite. Now, all of these rules are there for a reason. You want 3 copies of your data because hardware failures happen. That's what we're talking about here. Different types of media. USB drive is going to be in a physical location. Anything happens to that physical location, USB drive is no good. Cloud storage would circumvent that. And you want 1 copy offsite, again, because if you have a natural disaster, fire, earthquake, flood, lightning strike, whatever, if everything is in one location, that one situation can take out all of your backups. So make sure you follow the 3-2-1 rule, take regular backups, and make sure to test your backups at a regular interval. Test your restoration workflow so that when something like that does come up, you have a workflow you can follow to get back to a working state as fast as possible, because time is money, and we all know we don't have enough of either. And don't forget to clean out your physical PC. Dust is a thing. It collects like nobody's business. I live out in the boondocks, and I swear I have to dust everything like every other day. As soon as I get dusting, I can already see a layer of dust on everything out here. It is ridiculous. Dust is conductive. It's made up of particulates. So it can result in increased temperatures, which can reduce your system efficiency and reduce your overall performance. And it can also lead to earlier failure of your components. Your temperatures rise. Solid state drives don't like that. Hard drives aren't a fan of that. Your processor has thermal protections built in, so it really won't care that much. But if the dust accumulates to the point that it can't cool it off, you may not even be able to run at your turbo clocks. Another thing that can happen is short circuits. It's totally possible. Dust is conductive. You get enough dust in your power supply, you could potentially start a fire. There's built-in protections to try to catch situations like that, but I mean, it's software and hardware. Things can still go wrong. You know, defective units may have slipped past QC. Who knows? So better to avoid it altogether. As far as dusting your computers out, back in the day, they used to use those little keyboard duster cans. Um, weren't those things like $10 a can? And they were gone in like 30 seconds? Nah, pet dryers. Got one of those for my dogs years ago. You know what else it does great at? Dusting out your computer. It's a friggin' powerful little vacuum that blows. It's great. Just make sure you don't overspin your fans. So if you're going to use something like that to clean your computer out, just hold a finger on the fans before you hit them. They have bearings in them that are rated to a specific speed. Most of your computer fans aren't going to spin over 3,000 RPM, and the pet dryer will definitely make them spin faster than that. Let me tell you, it does make a cool sound though. And yeah, that's about all I got.
Well,
We have any questions come
fantastic.
up here?
Yeah, we had a good one. Someone mentioned that we had previously recommended an MSI laptop, and
Yes.
yeah, I saw there's some that certainly seemed viable, but obviously we can't address every single manufacturer. But I know we were having a discussion, of course, this morning about why we're not necessarily picking these gaming laptops, for a variety of reasons. So some things fluctuate, but maybe you can speak to that a bit.
Yeah. So the gaming laptops are still a perfectly viable option. There's nothing wrong with the gaming system as a workstation. There generally, if you're in the market and you start by looking at gaming machines, you have a very strong chance of almost blindly picking a computer that meets the minimum and potentially recommended specifications. The flip side of that is a lot of the gaming machines, especially well, for this one, I was going for ease of use, trying to simplify the buying process, giving you the tools you need to be able to pick them out. If you go to MSI's website to try to pick a computer, their spec sheet makes it a little bit difficult to figure out which one it is you need. And then when you try to go buy one, you can't actually buy one from them. You have to go to a third party's website. And then the one that you just spent 20 minutes trying to pick out may not be in stock at that one. So then you have to go back to MSI's website and then pick a different third party. And then the price might be different, stock available, things like that. So MSI is still perfectly reasonable as a computer. I just wanted simple options this time. A big thing with the gaming ones as well is pretty much every one of those computers now has RGB everywhere. And every time you turn one on, it just does its little rainbow puke dance. So if you're fine with that, those are fine. Personally, I have an Alienware laptop. I love the thing to death, but it is very awkward to use in a public environment because every time I turn the thing on, it's like I've got a dance club going off on my table. It's a little different. But yeah, MSI, Asus. I know the MSI Stealth and the MSI Raider lineup are both still perfectly good computers. Um, the Dell XPS line is just a little bit more professional in the sense that it's toned down. It's more geared for a work environment. But yeah, no, if you like MSI or you like Asus, I know Asus has a little 15-inch white laptop that has made like top tier for budget gaming systems for the last like 3 years running. I think it's like $1,400 with a 4 gig GPU, 16 gigs of RAM, and probably now a 12 core CPU. You can get that at Best Buy. I forget the model number on it though, but yeah, gaming machines are still totally reasonable systems to go with.
Well, fantastic. Well, I hope you guys all liked it. Get your little Christmas list ready. Time to get a new machine, and
I'm
have
gonna
a
need a
great
bigger
weekend, everyone.
stocking.
Right? We will see you guys next time. Bye bye.